So Fn is equal to sine n by n now. So if it's sine n by n, let's try to do it. Let's fix epsilon. So let's write an minus L is less than epsilon. Let's write sine n by n is mod is less than epsilon. And from there we got, so we have to find like this. Now this is where the issue comes in. So we have to find that n is greater than something. You have to find this quantity which is a function of epsilon. And this becomes hard. This is not possible. Even if you do it for 1 by n square, this will turn out to be hard. 1 by n square less than epsilon. So 1 by n square less than epsilon means n is less than root epsilon and greater than minus root epsilon. So it's becoming hard to find it out more. Sorry, 1 by n, I should say. So yeah, you can just remove this and you can say n is greater than 1 by root epsilon. But the basic idea is this, that for complicated functions, for complicated functions, even if we know the limit L, which is not probable, which is not easy to find, then finding n epsilon is a hell of a job. So the question should come that two questions should come. What's the use of this definition? And the second question is that then how do we find the limit? These two are the important questions right now. All of you understood the observation. So this is hard to find, okay? Because it's a complex function of a of a n. So this is hard to find. So understand, whatever we are doing is like a story. It's like we are attacking a question, we are understanding it, trying to understand a question, and for that we are getting a solution. And after getting a solution, we are trying to experiment it with more, and from that we are getting more questions. That's how science works, okay? And science gives you stories, and that's how, this is why I shared knowledge in this way. Did you understand this weird observation? Did you understand these two questions? The importance of these two questions? Yes or no? That's great. Okay. Just give me a minute. So I've already, told a bit about this in our in one of the videos I have uploaded. But what's the use of the definition? So from this we will understand what's. So you will see that this question, this small minute question shaped how the literature of mathematics and how the literature of sequences and series developed. So this tells you, this question shaped how the series sequence stored theory of sequences evolved. It's very interesting. You should learn in a way that it should be always a, it's in such a flowchart format that you always stay in your mind. You will never forget. That's the beauty of learning. That's the way you should learn always. Okay. Now how the theory sequences evolved. It's very interesting. Understand, our goal is what? Our aim is to understand it or find or proof. Find the limit of a sequence or proof its convergence. That is the aim, right? Now, as I have told you, there are two different ways out there. Number one way, now this is like the understanding or what happens. In convergence or divergence. So the one part is this behavior, and this part is finding the limit. So you can say this is kind of existential behavior. This is like the computational aspect. Okay. So I will probably give an example. Computation is like, for example, there's a difference between saying this function, this polynomial has a root. This polynomial has a real root, a real value, which for which if you put into that, it will give 0. Okay, has it? Existential questions. And there's a difference between saying that and saying that how to find the root of the polynomial. Okay, so computers are famous for doing this, how to find the root of the polynomial, how to find the root, how to find the limit. And that's a computational mind of the human brain. And the existential is like the behavior, understanding what's happening inside. You know, the creative aspect, like everything, like connecting the dots and the puzzles, okay, of the whole. So we'll see at the end of this course of sequences, we'll connect every dots and puzzles of the entire thing. So this behavior asks you about, ask you questions like, or you answer questions like, what happens if a sequence doesn't converge? That's the main question. What happens if a sequence doesn't converge? That's the main question we address in this behavior. Okay. Or what makes a sequence converge? What's happening inside? We'll see some conditions like convergence sequence are bounded, okay? And we will see some conditions like I have made a flowchart. I will explain you that today. You will see sequences as, you know, if divergent sequence are there, for example, why sign in is not divergent, like sign in is divergent. Sign in is divergent because if you plot that, it turns out that there are certain subsequences which goes to other limits. Okay, so the basic idea is that it's understanding, it's putting the puzzles, and this will be done in the later class, in the classes that will come in the next week. And this is the fun part, this is the beautiful part of it, that connecting the puzzles and the dots together, what's happening and everything out there. And there will be, I will take an final class where I will overview the entire thing, putting the puzzles together and showing you that, okay, this is the idea. One is this, okay, you will see learn concept like sequences, you will learn concept like Cauchy sequences, okay, you will learn concepts like subsequence and monotone, bounded. I will do a part of it today. Now all these interesting things, Bolzano-Weierstrass theorem. Okay, this helps you understand what's happening under the hood. Lim sublimate. This is the most important, lim sublimate, because this is the place where it gets the most confusing and students lose it because they don't understand what the mathematics is trying to mean. Like AN is going, let's say it's hard. So we'll explain you by, like, it's a story that unfolds in front of you. Why lim sub and lim was defined, an oscillation, these things creates an infrastructure of a long-term behavior of a sequence. You will understand from this behavior everything, every single aspect of this technology. Okay, these are the parts of a car, you can assume, and the car is to understand the behavior of the sequence, long-term behavior. Okay, whether it's divergent or convergent doesn't matter, but the long term view of the sequence. Now finding the limit. Finding the limit is where we will be looking a bit today. Not a bit today, but I will explain you the basic idea. Is that how the whole thing was developed. The whole thing was developed in this manner that this is how mathematics is. If you see any way how it's done, first, if you say differentiation, you have done differentiation, right? So if you remember, in whatever book, there is a differentiation list. Okay. So the definitions are used to find two things. So as you can see, the sequence can be defined in terms of f of n or recurrence relation, right? Whatever it is, for f of n, it's helpful. So what's done? Finding the limit when the function is analytically defined. This is how it's done. So using the actual definition, they find a set of usual limits. A set of usual limits. A set of usual by a set of usual limits, I mean 1 by n goes to 0. Okay. And they prove it using those things. And they set an algebra. So what's this doing there? These are the building blocks, the Lego blocks, okay? And these are the bricks, and this is the algebra of limits helps you attach it. It's just like the adhesive, okay? So for example, one way is that I will tell you, it's saying that if an is less than bn, then and if an bn goes to b and an goes to a, it implies that a is also less than b, right? So how can you use this in let's say we don't know the limit of sign, but we know 1 by n limit exists. So what we are using essentially is that let's say you take sine of n by n, you take the modulus of it, okay? So it's less than equal to, sine n is less than equal to 1, right? Mod sine n, so it becomes 1 and n, and this is greater than equal to 0. No, that in this limit is 0 going to 0. Hence this limit must be going to 0 because a is less than equal to 0 and greater than equal to 0. The only possibility is 0. This is something called squeeze theorem. We will do this in more details. But the basic idea is understand using the knowledge of 1 by n, it found the limit of sine n by n. So what it's doing? Essentially, there is a set of limits, known limits. They are using those epsilon n epsilon definition to find it. And using this known limits, they are passing through a filter of algebra of limits. Algebra of limits is if you add two sequences का limit, they add up. If you divide two sequences, the limit they add up. So essentially algebra of limits plus inequalities. Inequalities are limits. From this, you can find out new limits. Just like you find this one. So the NF cell and this definition is used to find this set of known limits, the known results, and also prove the algebra of limits. And then using that technology, we find new limits. So now your job is not to learn this, like you have to, if you have time, I learned this in my undergrad. If you have time, you should learn this, but understand that we will be knowing this, and we'll be knowing this, and then we'll be doing this. This is one way. This is the algebra of limits. Understand if this will only, like this known limits are certain functions, certain results. So it will only be useful like to find for analytical method, and the algebra of limits and inequalities will be useful for the recurrence relation. The basic idea is that use the past knowledge to predict the future, get the future knowledge. That's the basic idea. This is the past knowledge used to find from the basic definitions to prove this, and using that we find the new limit. Just like we got an example. We will do more on this, but I'm telling you the basic idea, okay? So this is one such basic idea. one such basic way of understanding what's coming in the front. So we will be like, for example, there are other properties like monotone convergence, monotone bounded theorem. If a sequence is, so we will learn all those techniques to understand and find those limits. Okay. So we'll learn techniques here on the left hand side, and on this we will understand the puzzle pieces together. All of you understood this? Yes or no? Okay, that's great. Super.